Hi, thanks so much. Thanks for making the time to come to our panel on AI innovation for game experiences today. This is my first time moderating a panel, so I am a bit nervous, but I'm really lucky to be joined by these pros on the stage with me. So I think I'm pretty excited. I think it's going to be an exhilarating conversation about the power of research and development of new AI frontier research and the challenges of going from developing raw technology to turning those technologies into a product, into tools. And today's discussion is very much about R&D, prototyping. So we're not going to be making any product announcements, and we hope to have that open discussion on the stage with you all. So firstly, I'm thrilled to be joined by such a fantastic panel today. I've worked with these folks in various different roles over the years. So I'm going to ask the panelists to introduce themselves. Katja Hofmann, you're a research leader and you've devoted a huge portion of your career to researching gaming and AI and empowering game developers to do more with AI. So would you tell us a bit more about yourself?
Absolutely. And first of all, thanks so much for having me. It's so exciting to be here. It's actually my first time at GDC, so I'm not quite sure what to expect yet. But yeah, I'm Katja Hofmann. I'm a researcher at Microsoft Research, and it's my 12th year there. For me, this role really combines two passions that go all the way to my childhood, to my teenage years. When I was about 12 or 13, my parents thought, this was the early 90s, so my parents thought, maybe it's a good idea to invest in a computer. And because my room was the only place where there was space for it, this ended up in my room. And so now I'm there with this gadget, and nobody around me knew anything about computers. I had to discover everything on my own. I found a book on the flea market, taught myself how to code in QBasic, and I discovered my first video games. So I have all these memories of playing Prince of Persia all the way to the end. I was very proud of that. And then also that feeling of really free exploration, because coding was this thing where nobody else could tell me what to do. And I had this feeling that if I can come up with it, then I can maybe code it up and make it real. And so today, in my role as a researcher, I feel like I still tap into those same passions. I get to explore research, figure out what is this next challenge in AI? How can we make things possible? And at the same time, there's this playful side, and having all these conversations with our colleagues over at Xbox and many other amazing people like you all. And I get to work on all this with a fantastic team. So it's just really, really exciting to be there. Maybe if we can, I'd love to tell you a little bit more about the place where I work. So this is Microsoft Research, two locations where I'm based a lot. I'm normally based at the office in Cambridge in the UK, and also work a lot with people, for example, in our Redmond office and other colleagues worldwide. And so Microsoft Research, if you're not familiar with it, it's an industry research lab. It's part of Microsoft. There's about 1,000 people worldwide, and it's kind of like academia in the sense that it's very multidisciplinary. It's kind of like a cross-section of multiple academic departments, and that's one thing that makes it so powerful. If I need an expert on any other topic, not just in computer science, but very broadly, it's pretty likely that there's someone doing fantastic research, someone within Microsoft Research. But then also there's things that are very distinctly different from academia. I already mentioned our fantastic colleagues in Xbox. So we also have all that dialogue, all that surface for interacting with others, which helps us guide our research. And to me, that is a really, really fruitful combination. And I just wanted to briefly call out my fantastic team there on the next slide. This was sometime last year when we did a play session of this game, Bleeding Edge, from Ninja Theory, that we've been working with for a while. And it's just a super, super fun team. Everyone is such a creative person, and I love bringing that team together and working with them to figure out what's next.
Thanks, Katja. Thanks. And then Kylan, we've done a few panels together where we've talked about the potential of AI, especially language models, to deliver new kinds of dynamic gaming experiences. So can you tell us a bit more about yourself and what you do?
For sure. Thank you so much. And I'd like to echo these guys. Thank you so much for having us here and taking the time to come in and join this talk. So I'm Kylan, CEO of Inworld. My background has been in AI research largely since I began, but probably more importantly, I've always liked fun, and I'm a hardcore min-maxer. To just give you a flavor of that, last few weeks have been a few hundred hours in Balatro, Vampire Survivors. I picked up, and I also have my RPG phases, but only ones that really allow me to min-max. So I've been trying Metaphor. It's good. I'm enjoying it. I love the story, but it's not, necessarily hitting that min-max or that flavor. Souls-like games as well. I can't get enough. So back to where that comes together is AI for me. I started out at DeepMind, largely on the research side, on the language front. So we were at that point kind of just looking at things in the language space, and I did a lot of work across Google to apply AI to different product areas. And what was interesting at that time is I consistently saw a pattern where AI was quickly moving into enterprise applications and augmenting professionals. But everybody in this room, I believe, is interested in how can we entertain the world? How can we give people fun? And it's a very different problem, for example, than how can we do a legal contract review? How can we produce marketing content? These are not necessarily fun contexts. They're trying to produce a specific task. And I still feel like AI is very biased in that direction. How can we create ultimate intelligence? I don't need ultimate intelligence when I'm playing Vampire Survivors. I need some hardcore bullet hell that drives me insane, almost gonna stimulate every sense that I have. And I think that's why I'm so interested in the emergence of these two worlds of gaming and AI, because I think it pushes the AI industry towards something that benefits everyone, not necessarily our spreadsheets and our documents, but the things that we actually do in our free time. And I think this will become increasingly important because, apart from even what we're discussing here, AI and automation are going to change the way that people work, how they have their time, how they're able to spend their time. And I think that, I believe, hopefully, people in this room believe that games are a great way to do that. And I believe that kind of bringing these two things together is actually how we help AI entertain the world and bring fun to it as well, beyond just productivity. And I think this is just a fundamentally important thing that we all should consider as this moves forward, because this technology is coming and it's advancing. But I think it's the people in this room and that have that opportunity to make it something that is enjoyable and not necessarily just making us work harder and faster. So that's where I'm coming from, and I know today we'll be talking through a few kind of the challenges that we've been facing, I think, in how we move into production. And that's where I've been focused on really deeply is coming out of research. There is amazing stuff that we're able to create, but getting it in the hands of millions of people is a very different problem and has a completely different set of problems, actually, than most of the things that we look at with AI. And so as we look towards things like local inference, local logic, things being able to compiled and scaled without marginal cost to scale, this is how we need to operate as game developers. And I think there are some fundamental issues right now with the AI ecosystem and how it fits within gaming. And so we'll talk through some of those, but I do think it's something we need to confront as a group. It's not something that one company can solve. It's rather, I think, a collaborative effort of how can we make AI work in this future for gaming and entertainment. And so, yeah, excited to chat with you about that.
Yeah, and I think what's really interesting is that at Inworld, you've been working with multiple game studios, different creative teams, to try to bring their creative vision to life through using AI to facilitate some dynamic experiences, so that each game experience might be different for the user playing it. I have a video of some of the work so that folks can see.
Yeah, let's put it up. Yeah, so I think the key thing is that I want to make one note, which is a lot of AI, I think, as it's discussed in gaming, is how do we augment workflows? How do we create efficiency? I think that's really interesting, but I think the kind of most interesting thing long term is how does it actually affect the player experience? How does it create new experiences? Doing things faster, cheaper, better is always good. That's cool. But I think we're kind of going to pretty soon hit kind of a threshold there. And so I think what we're really interested in is how can we create more fun and new types of fun? So anyway.
Nice, yeah.
Where should we drop?
Canyon Crossing got the most votes. That's where you rage quit last game. You brave enough to try again?
The rabbits eventually become too powerful to continue their attack, sparing everyone from their rats. Yes!
Nice!
There are important docks in a vault on the villa's second floor of our worst enemy. Bloom says you're the one to help us tweak the plan.
Milo, your bet is as weak as the Scourge's hold on Planet Mojo.
Brooka, your raise is as bold as your taste in sci-fi references.
Can you gather some fruits?
Of course, contractor. I'll get right on it. Just don't expect me to peel them for you too.
Make me a world set in medieval times.
Forgotten your own company, have you?
No, I'm with Fazbear Financial.
Interesting, because I could swear you told me Emberstone Enterprises before.
Thanks. In this session, it'd be great to hear your perspectives on different teams you've worked with and their thoughts on where AI really makes a difference. Finally, hi, my name's Haiyan Zhang. I am a GM of AI Innovation and Science at Xbox. And so I've been working in gaming and play for about 20 years. And I think one of the reasons that I really work in games is I feel like kind of growing up, gaming really kind of saved me. I remember being like 8 years old. I was this like very nerdy immigrant kid who didn't speak English very well. And one of the joys of my week was to boot up on multiple 5.25-inch floppies, Decathlon, and be like, the kind of mashing the keyboard to run or throw a shot put. And it really games were a way to kind of transport me to this new realm where I could, explore new ideas, new sports. And also, like Katja, playing games led me to learning to program because I wanted to create some of these experiences, and it was GW basic in my case. But games really opened up a world for me of developing technology and kind of led to me having this technology career. So I owe a lot to gaming. And I wanted to talk a little bit more about our perspectives on innovation and how we think about research as it goes on that journey to product and to tools. So I've been working with Xbox on and off for about 14 years. And at Xbox, we're just incredibly lucky to work with so many creative teams, whether they're inside of Xbox, they're first-party studios, or many teams across the industry. And we also get to connect with the developer teams, but we also get to connect with players and build player communities and help players find the great games and maybe change their perspectives by allowing them to play through the Xbox platforms on PC and console. And as an industry, gaming, I think, has always been at the forefront of technology, innovation, and adoption. We're always, as games, we're always trying to push the boundaries. We're always trying out something new. Hey, my game is going to be something different. I'm going to bring a new experience to people. And to do that, we take pieces of technology, whether they're ready to go or whether we're just like, hey, let's try out this new algorithm. And the magic of games is that we take these new pieces of technology and we turn them into tangible experiences that people can feel. People can actually play them, can actually go through that experience and know what that technology is about. So innovation is really the lifeblood of the games industry. So games like Doom or World of Warcraft, really pioneered new networking technologies to enable online multiplayer for the first time. And these technologies then go on to inform other industries. So online multiplayer then goes on to help build social networking, help build online collaborative systems. So in many cases, gaming is that kind of engine to drive innovation in the rest of society. And at Xbox and at Microsoft, we're just very lucky to tap into that broad spectrum of where technology starts to emerge, to developing new tools, to figuring out product market fit, figuring out what people want. And that's why it's great to have this panel of working with Katja, who is situated in research, and then also working with external companies like Inworld, who's really looking to collaborate with game teams to bring those technologies to life. And I think everybody in this room knows that when it comes to delivering great experiences, technology doesn't sit in isolation. We're really looking at experiences, first of all, through the lens of user desirability. Are the features we're trying to develop supporting player and developer needs? And then what are the technologies that make that feasible? What are these new things that we want to deploy that's scalable, that's reliable every single time, that a player can come and have a solid experience consistently? And then ultimately, we're packaging that all up into, hey, what's the visual quality? What is the actual experience? How does it feel to jump and run in that level? How do we make these games accessible to everybody? As Kylan said, how do you make the technology scale? How do you mitigate for overhead costs with these new technologies? So really, we think of innovating great products as sitting at the intersection of considering all three of these lenses. So today, we're gonna talk about the power of research and development, of starting out with new technology research, and that journey from just pure tech to tools and products, and some of the challenges as we apply that lens of user needs and product market fit. And also, I think we want to acknowledge, and I think Kylan knows this very well, and Katja as well, that there's a raw piece of tech, and we're just trying to figure out where is it going to go. It's on a journey. It could manifest in multiple different kinds of tools and products. As we've seen, large language models, going on to be a chat bot or becoming like supporting vibe coding or different aspects. And so part of our work is really just trying to figure out where does this technology really make sense? And that could be in lots of different places. So with that, I guess, Kylan, you've been on this journey, starting with large language models for the last few years. What are some of the challenges? What are your perspectives on this journey?
Yeah, for sure. So in the context of what we found, we started out with this question. So just for context, when I was at DeepMind, the challenge that I had was how do I integrate large language models into lots of different products across Google? And it was hard. Even at that point, I can tell you, like, some of the things that you now see in your Google search have literally taken almost 10 years to get there. And so the challenge was, how do we generally integrate that? And so when we started out, we were asking this question, just like, how can this even make sense? And so the natural thing that a lot of people gravitated to, for example, were like NPCs, talking NPCs. And it was almost just testing out those use cases that made sense. And as we've gotten deeper, we've realized all this stuff is possible, but the kind of challenges actually come down to the realities of the tech, of what are the real difficult issues that are facing us. And so I have a few kind of like main points on this that.
You want me to?
Yeah.
Oh, okay.
So these are just some main challenges that we've kind of encountered over time. So first is cost. The reality is, when you're looking at something, even like a ChatGPT, very basic instances of AI, it is extremely expensive. Extremely expensive. We've had one of our customers who was starting out, and they hit like 60K users in their first few days, and it was costing them something like $15 per day per user. This was before we started working with them, to be clear. So $15, anybody in this room knows $15 per day per user is insane. There is no world in which you're going to scale a game like that. I don't know what kind of gaming users would pay that much for. I've never encountered it. And so there's a fundamental issue where we need points on a cent per day, not $15. And yet the way that AI is built today assumes these very complex, professional tasks like extracting information from a legal contract. You need thousands of calls per minute if you're going to make a game work. Those are two very different worlds. And so I think there's an issue here, which is cost, which is primarily in the end state solved, I think, by all on-device inference. Everything needs to be on device. Now, there's an in-between world, which is consumer devices aren't there yet. So I think we need to basically figure out a way to bridge that, which is what we call hybrid computing, which is you try to do it locally, and if the consumer device isn't available. For example, if you have a brand new 5090, great, run it all locally. If you've got a 10-year-old Dell that has some Intel chip that I don't even know the name of, you're going to run it on the cloud. And so you have this way of serving all consumers in the same experience at sort of minimizing the cost. And then as consumer devices advance, we continue to bring more of that locally. It's one of the solutions. Scale is another one. There's something very funny, which is when you read a lot of the AI hype on your LinkedIn feed, you'd get a lot of belief that this stuff is ready for massive scale. I can tell you it's not. If you try and go to an LLM provider, a cloud provider, and say, hey, I'm going to serve 10 million users today, and I'm going to expect 5,000 queries per second, 1 billion tokens per minute, they're going to say there's no way. We can't support it. So there's a lot of real challenges here, which is like, well, how do I do it then if even the biggest companies can't support that? And that's where we need to get creative as a group. So we need to use multiple clouds, we have to do more local inference, and we just need to think about that in a different scale. But when we're talking about millions of users a day, which are each making thousands of queries per minute, that's a lot of scale, that a lot of things need to change for it to work. On the quality and latency, this is kind of going back to my point on entertainment. AI today is also, and a lot of innovation is built around information or productivity, so there's a right answer. Each of us in this room has a different preference for what we like and get entertained by, and so the content for us needs to be different. Mobile apps have got very good at things like personalization. But I think there's a fundamental issue there, which is how do we ensure that these experiences are being adapted to each user's definition of fun? And that is a very different thing than saying all of us in this room know that, well, maybe there's different preferences, how many times a day does the sun rise? There's one real answer to that. But in reality, when you're thinking about in a complex world of different things, there's a lot of different answers for every question. And control and ownership is the next one. So on that front, it's a matter of, I don't think that everybody wants to build games around APIs. I think having an API that runs a lot of your intelligence in the cloud that you're not controlling is something that fundamentally removes a lot of your control and ownership over that. And also, I think, kind of creates what I would call a rental model for innovation, where you're actually renting technology that you don't own long term. And I believe for it to work long term, a lot of that needs to be built into your applications and needs to be owned end to end. In the same way that if you're investing in a property and you were renting it and you invested a lot of time in the infrastructure and everything around it, and then all of a sudden your landlord took that away, that would feel like a bit of a loss. And so I think there's a question of how do we also bring more ownership around innovation and technology to different groups. And that's tied as well to this point on data sovereignty. So you need to be able to collect the right data, which means you need to have great telemetry built in. Anybody working on games knows every single little user action is worthwhile. You can't just track a few big things. You need to capture as much as you can. And so when we think about interactions with AI as well, we need to be capturing even more data so that they can have that nuanced information so that they can make those decisions as to what's fun for each user. And I think that is extremely important. And when I say sovereignty as well, it means you need to have the right to take your data, regardless of the models that you're using, and to be used across different experiences and improve it into the future. Which comes to the last point, which is any game, I believe, is not built for a month. It's built to last for years. Models, if we look back at the last 6 months, there was, I think it was Claude 3.5, then there was O1 that came out from OpenAI, then there was DeepSeek, which came out, then there was O3 that came out from OpenAI. Okay, as you can see, that was like the last, 8 weeks? How many models came out in that time? If you built your game around one of those models at a given time, it's going to be outdated in 6 weeks, let alone in 5 years. How do we build in that long-term evolution so that the models actually underlying these games evolve over time with the player base as well? And I think that's a critical point. If you don't build in long-term controlled evolution into your experiences, they will stagnate because the AI will feel old. It will feel basic very quickly. And so you need to figure out ways, whether that's pushing updates to local models, connecting to the cloud models that are evolving, working in fine-tuning loops. All of those kinds of things are really important to ensure that your game is adaptive. And I think this is a key to long-lasting AI games. How do we ensure that they are able to evolve with our user bases for long periods of time? Because a game that is powered by AI today will look very different from a game that is powered by AI in 5 years. Yet I would hope that the developer who launches that game today still has their game live and is loved by millions of users in 5 years. So yeah, those are my points. And these are real challenges. We're encountering them, but also it's not something that I can solve as an individual person or individual company, which is why we're continuing to collaborate with great people in the industry.
Thanks. Yeah, so thanks, Kylan. So the journey is challenging, it's hard. So now we're gonna travel to the beginning of that journey to look at some new AI research. So Katja, you led a recent publication in Nature magazine for a new kind of game model. Can you talk a bit about that?
Of course, and just listening to you, Kylan, it's so fascinating to see just that whole journey. Research and technology at its very beginning, as we have in our team, and then looking at, well, to actually make that useful, to actually get that in front of people, all these additional steps that are necessary. And so, as Haiyan was saying here with Muse, we're very much at the beginning of that journey. We are pushing the boundaries of AI and what is becoming possible there. And for us, this really started from two very complementary places. On the one side, the AI research, so this really open-ended exploration of asking ourselves questions of what if we were to apply models similar to large language models, but to this entirely different medium of games, and what becomes possible when we do that, as well as soon as we saw first signs of life, then that dialogue with creatives, not with a view of like immediately turning that into a useful tool, but just as a guide to help us on that research journey to see what are real challenges for people today. How can we start to build insights or ground our AI research early on so that we start to develop this understanding of what would be the capabilities that people would actually ultimately need in order to kind of have a chance of moving to useful technology, tools, and eventually products. And so to tell you more about what we did here with Muse, so Muse is what we call a world and human action model. It's a generative AI model that is trained to essentially currently simulate an existing video game. And kind of, to me, the first fascination is the degree to which that is possible now with Muse, our first world and human action model. And maybe if we go to the next slide, yeah, we can see a first set of clips. All these clips are simulated versions of a game called Bleeding Edge that was developed by Ninja Theory and was released on Xbox in 2020. When I look at these clips and I don't know whether they come from our training data, the real human gameplay, or actually generated by our model, then I have to remind myself because they're becoming so accurate. And so you can see that the model is able to, for example, simulate the visuals, the 3D geometry, the way characters interact with the power cells. For example, here you saw in that top clip, they're able to simulate other players in the scene, combat, and all that. So to me, it's just mind-blowing how that is possible. And so on the next slides, I want to give you a little bit more sense of what's underneath to actually make this possible. Here, we started with, in a collaboration with Ninja Theory. As mentioned, that's the developer of Bleeding Edge. And our collaboration actually goes back all the way to 2018 when we had these kind of broad explorations, those discussions of where is AI going and what will eventually become possible. And one kind of shared insight that we had is that kind of having access to training data that is unlocked in a responsible way will be a very solid foundation for driving the AI research and driving this understanding of what is possible. So this is when we started working with Ninja Theory to unlock a large amount of human gameplay. And we collected over 7 years of continuous human gameplay, altogether more than 1 billion images and controller actions. And what you see here on the screen, the reason this is a pixelated video is because it's actually at the real resolution at which we train the model. So we try to train models at the kind of the smallest possible models we can get away with to just show what's becoming possible. And so here we rendered the training data at 300 by 180 pixels. And so this is literally what our model ingests. Real human gameplay, the visuals on the screen, and the people's controller actions as they were playing the game. And then on the next slide, we'll see an overview of the model that we trained from this. We started this specific line of research about 2.5 years ago with the first goal to understand what does this scaling up of machine learning look like? What does it look like when we apply the patterns that worked in large language models to this new medium, to this actual human gameplay data? So here on the screen, you see two components that we ultimately settled on in order to train this model. First, on your left, you see a sketch of an encoder-decoder architecture. So this is trained to create a compressed representation of the visuals that a player would have seen on the screen. And it's able to also reconstruct those visuals from an embedding. And so this embedding is a sequence of tokens or numbers. And we then use that embedding, that sequence of tokens, and put that into a transformer model. So this transformer model, the backbone of a lot of the today's large language models, applied in a very similar way. So we construct a sequence of data where we have the numbers that make up the encoding for an image, followed by an encoding of the next controller action that was issued by the player, followed by the next image, followed by the next action, and so on. And we train this model to do next token prediction. So we purely say, here's the sequence, now give me the next number, and then give me the next one. And this is an autoregressive model, meaning that every single prediction we then feed back into the model, and so we can keep going. And purely from that quite basic predictive recipe emerges the sophisticated understanding of the game that I just showed you on the previous slide. So this understanding of what are the regularities that make up the 3D geometry, the way the game reacts to the player, the game physics, and characters' abilities, and so on. So to me, as an AI researcher, it's still fascinating every time I talk about this. And so then, going to the next slide, I want to give you a view of, it's almost like a way to look at how the learning is, how the model is learning over time. When we hit next, you'll see first the ground truth data. So this is a clip from the actual underlying game. And you'll see a character here destroying a fuel cell, moving up the stairs. And then this is a character called Azrael that has a flying mechanic. And so you just saw that this character with its special ability was able to fly over this open space. If we go to the next clip, we see that there's some signs of life. It managed to destroy the fuel cell, but we still see problems with consistency. And so after a couple of seconds of autoregressive prediction, the scene dissolves. If we train 10 times as long, we see that consistency is no longer an issue. But the model hasn't yet picked up on finer game mechanics, for example, the flying mechanic here. And so it dropped the character to the ground instead of actually using the flying mechanic. And we keep training, and you can see how the model is picking up a more and more fine-grained understanding of the game dynamics, all the way up here to the flying mechanic, where after a million training steps, the model has figured out, okay, there's this flying mechanic, and it just can cross over this open space. I just love this demo, and it was one of the first times we saw like what the model was actually learning. Then from these signs of life and from the research, as already mentioned, we're trying to get insights from game developers early on to help us guide, to help us figure out where this technology could be heading. And in the context of this, we developed what we call the WAM demonstrator. And I just have a few seconds to give you an impression of this. This is a prototype tool that we developed just so that people could kind of directly interact with the models that we were building. So as we play this demo here, we see an example where we start actually from a promotional image from the game Bleeding Edge that was never actually used in the gameplay. And we can see that we can prompt the model with that image, and then it can kind of imagine or generate multiple continuations of how the scene might play out over time. We have this branching mechanism where you can generate multiple possible continuations. And so we're trying to figure out what are those patterns, for example, of iterating with the material, refining, changing some of the visuals so that creatives might one day use this to have control over, for example, how they ideate or prototype with this medium of these world and human action models. And if we go to the next, I think to the next video, oh, no, that was the previous one. Okay, so you already saw there, for example, you can also then just pick up a controller, you can prompt the model with the visuals, with actions, with a combination of the two to really guide that interaction, that ideation process. And so we're hoping to use this to tease out exactly what is needed and kind of provide an envisionment of where this kind of technology could ultimately lead to.
I want to point out that this is all open source, and folks can go and download the model of Hugging Face or use it, deploy it on Azure Foundry.
Yeah, exactly. And the WAM demonstrator is there as well, so you can go and play with this today.
I also want to just couch this in its early research. I mean, it already looks really good as a UI, but it's early research. So what does the model actually do today?
Yeah, we really think of this as kind of like an AI simulation of a game, or I don't even like to call it a game because it's really like playable scenes. You can train the model on gameplay from an existing game, and then we can show that, yes, it is possible to pick up the game visuals, the geometry, the game dynamics from that. So you can now have a model that captures a small playable scene, and you can iterate over, for example, how could gameplay evolve from this particular situation? Is that it?
And then Kylan, as a tool maker, what's your perspective on this type of research?
Yeah. So I mean, I think the first thing is I'll probably speak for some folks. When we immediately look at something like this, there's kind of this gut reaction, which is like, oh, this would never work, right? This is how people often respond to things in research. And there's reasons for this, right? Like it would be hard to expensive to run these things on the cloud. But I think over time, it's better, rather than kind of checking that gut reaction, is like, where might this actually work to solve a real problem? So for example, prototyping, I think, is a great example of where this could be useful. I'm imagining a game, I'm working on it, I'm not gonna scale it to millions of users, maybe a couple people, and I'm gonna try something like this to say, do the basic mechanics, does the world building, does all of that kind of stuff work out? And then I also think there's more specific problems, where I believe that more likely than us having full games that are being generated in real time, it's more likely that we would generate the code of the game and actually be able to deploy it at scale. However, we were talking before that, for example, you might prototype with something like this, and then once you get to something that you like, you feed that into a code generation model, which actually builds a production-ready, shippable version of it, as a, what the future of development might look like in 20 years. Today, though, where I think things like this are really interesting is, imagine for animations. Character animations are really difficult and take a lot of time. So imagine you had a gray box around a character in a real project, and instead of actually articulating the characters, doing mocap for the animations, you were able to use something like this to create an infinite amount of different animations for that character in real time, as a very specific application. And I'm sure there's many more that people in the audience can think about, but my point there is, I may be skeptical of taking the research as it exists today and scaling it up into production. However, I think it inspires new directions in terms of how we can do game development in the future, and also can, in a more precise application of it, solve real problems that we have today. For example, animations. It is very, very difficult to create millions of animations. Very, very difficult. And I do think there's spaces like that can be do. And I'm sure there's many more that I am not aware of that folks would want to apply something like this to. So I'm very excited to kind of see how it works into it, even if I don't necessarily think we'll have full-scale video generation models as the way that we run games in the future. I think it will find its way in there.
Thanks. And then Katja, I know in your research, your team actually interviewed 27 different game development teams, and did they also, what was their perspective? Did they also have additional ideas?
Yeah, we engaged with those game developers from even before we were fully able to show the capabilities of the model. So we went through different rounds of iterations, first with what we call the design probe that was actually implemented in Unity, which was looks like prototype without any actual AI under the hood, just to tease out, well, if you imagine this and this might be possible, where would the limitations be? What would you experience as challenges? And we were able to tease out some key requirements that for example, the ability to iterate, to not have something that kind of regenerates from scratch every time, but something where you kind of have that continuous interaction, where you tweak, where you make sure that it is exactly the way that you want it to. Right? And so from those insights, we were then able to extract model capabilities that guided us as we were putting together the model design, and that guided us in our evaluation of the model. And so I think this dialogue, having that really, really early on is really crucial. Then after some of the research was completed, we went back to them and had a session where we were just sharing insights. Hey, thanks so much for joining the research. Here are some of the things that we've developed. And some of their reactions were actually quite similar to what Kylan mentioned here. There were things of, okay, this might not work, but then they keep thinking, and over the course of an hour-long conversation, there's all these different ideas of, wow, what if we imagine this? And so this is something fascinating to me as well. You start from the research and the technology, and it almost feels like there's all these possible branches that are starting to come off of it. And so today, part of kind of going back to my kind of teenage bedroom, kind of working with this computer and this fascination of, we just don't know. It's opening up a space, and who knows what will be possible. And if we kind of keep engaging in this dialogue, we can drive this in a really, really interesting direction, and we can pick the branches that we think are going to be the most fruitful.
Yeah, I love that.
So the Muse research work is still early days. So I want to just talk to Kylan a bit about your work with other models, with language models. And language models have been scalable, production ready for a few years. But it's also taken a few years for us to see some experiences where a language model might bring some dynamic interactivity to a game or a game-related tool. So Kylan, can you talk us through how you're seeing language models show up and where you're starting to see these experiences show up and where that might be valuable? Yeah,
so I think one of the interesting things about everybody's very biased when they first look at language models. And I think it's largely because of the way that AI is developed to kind of replicate human type of intelligence, where we often think like characters first, dialogue, speaking, whatever it is. And that is, I think, where a lot of it still sits. And the question then is, how do we scale that up and make it production ready? So we have one customer, Wishroll is the company, and Status is the game behind it, which you should download the App Store right now. And it's one of the most creative applications I've seen of AI, where they actually created a game that is a single-player game where you situate yourself in another universe's Twitter. So you're in like another, imagine you're in like Harry Potter Twitter or whatever your favorite Twitter universe is, and you role play as a character in that world, and you play it. And they've hit like hundreds of thousands, almost millions of daily active users, and it's really taking off. But the scale there is really challenging. So their cost, efficiency, latency have become an extremely hard challenge that we've worked with them on. And that's where I think there's like these matters of like really creative, amazing games that just require those deeply technical optimizations to make work. And that's at the simple level of like creating text content. On the other side, we've had some engagements, for example, with Streamlabs, which is part of Logitech, where we've looked at how do we create a multimodal agent that can understand game state, can even understand system state, your GPU, how consumed is your RAM, all of those different things, as well as actually ingesting real-time video, ingesting player comments and information, all of that with millisecond latency. Those are a lot of things to take into account when you're trying to have a complex response. And the response might be, for example, dialogue. It could be system changes. Okay, I want to overclock my GPU. I want you to change my camera settings. So the complex inputs, the amount of multimodal input to amount of multimodal output is immense. And so you need to make that work with millisecond latency is a very, very difficult challenge. And so that kind of comes back to some of the things that we're thinking about. Plus, it needs to be really engaging. So the character needs to be entertaining, comedic, not like a informational chatbot. And so working with Streamlabs on this, we learned a lot about, I think, what it means to actually make these things work in production. And we got to work also with Fortnite on this. And so we'll have a video in a second. But there I think what really came to me is we need to push a lot more locally. It needs to kind of have that kind of at least local option to work. We need to think also more broadly about all the different types of input to the agents in the terms of actual game state and code. Often I think we think in terms of visual or text input, but really games are a bunch of code, and there's a ton of great information in there, and it's a living thing. So how do we bring that in? And ultimately, it does work, and it can be incredibly engaging experiences, and I hope this is kind of just like showing one part of the light of what I believe will become a more standard of these agents that are actually able to live alongside you as well in terms of these games.
Yeah, so we've got a video. I think Logitech showed this at CES.
Yeah.
And I have to say, I think me and a couple of folks, we saw it and we were like, oh, I think that totally makes sense, because if you're a streamer, to have like a virtual co-host that's like doing stuff in the background, optimizing or answering questions, could be like actually super useful for the streamers.
Yeah, and we had like this is even a while ago, we worked with one streamer who integrated one of these kind of streaming assistants and had a 300% increase in daily donations. So it's like, it actually caused a real impact as well. So it's not just, it's good as well that it's having fun, but it has a real impact as well for the people using it.
Let me.
Loads.
Hey there! I'm your intelligent streaming assistant. I can join you on stream as a sidekick, help produce your broadcast, and configure or solve any issues with your stream. As your sidekick, I can interact with your chat, answer questions, and I'll make sure to let you know when you miss that key headshot.
All right, chat, let's get some wins. Where should we drop?
Canyon Crossing got the most votes, but that's where you rage quit when you couldn't clutch it last game. You brave enough to try again?
Hey, if chat asks, I answer. Let's drop.
Good luck. This might be a quick one. I can also act as your producer, completely in the background. I'll adapt your stream to what's happening in game. When something exciting goes down, I can trigger audio, play videos, change scenes, and much more.
Did you see that? That was insane. Can you save that clip?
Clipped it for you. Chat's asking to watch.
Give the people what they want. Let's see it.
By the way, you missed a tip while you were playing. Brian came in big with $25.
Brian, thank you. This one's for you. In a cone. Dead. That was insane.
And lastly, I can help you set up your scenes or even troubleshoot technical issues. Plus, I'll be monitoring your stream to make sure everything is running smooth.
Oh, sorry about that, chat. As I was saying, this is the future of live streaming.
Nice. So I gotta say, I started watching this, and that avatar is like very obviously not human. The eyes don't blink or move.
I'll just say this: I did not choose the avatar, and I would have had a different option. Not on record.
But I think it's a good design choice, because you want to make it really obvious that it's not human. It is an
this
AI
is true.
bot, right?
I do think we have always a tendency towards like hyper realistic avatars, and I love anime, and I prefer like more stylized ones personally, but I don't get to represent everyone.
So I think it's interesting that even with these AI features that are rolling out and providing value to players, there's still this like gap, right? There's still the uncanny valley gap, or there's still seams, gaps in the technology. And Muse, starting out, this year and moving forward, there's just more capabilities that you're working on for that model. Now, before, when we talked about Muse, we were seeing this kind of like generation, the models imagining what would happen in the game in this particular scenario. But recently, you've also unlocked some new capabilities. Do you want to talk about that?
Absolutely, yeah. And a lot of those capabilities are now coming surprisingly rapidly, even to me, as we engage with people more broadly. Some of them coming out of the collaboration and conversations with Haiyan and her team, for example. And so as people are seeing this technology, as you were saying before, they can imagine different futures for this and how this could light up, for example, new experiences. One of the things we've been working on is to try and make the model real time. And I think we can show a live demo of this today, which is always super scary.
Okay, so I've got my controller.
So, yeah, Haiyan has the controller here, is controlling this character, and everything you see there on the screen is generated in real time on the fly by Muse model that is running in the cloud. Well, it's actually running in Building 99 in Redmond on an H100. And so you can see some of those capabilities today. You see that this is very much a research prototype, and it's actually really only working for a single person. So this is a very unique experience today. It's trained, as we saw before, at this 300 by 180 on those images. So this is the resolution it produces. And this currently runs at 10 FPS. Which feels smoother than what you usually think of as 10 FPS because it's really generating images in real time, but it takes controller input at 10 FPS. And so this results in an experience that is already, to me, surprisingly consistent. You can navigate the space, you can go up and down the jump pads. You can modify things on the fly. So, for example, you can switch to a different scene, as Haiyan just did here, or you can copy and paste in elements like the power cells that we see on the right. And so you can already get a sense of how kind of you can start to directly manipulate what's going on the screen. And because everything's generated on the fly, you can start to imagine what this could lead to in the future.
So what Katja talked about is as you trained the model, you discovered it had capabilities like you could drop in an element, like a power-up from another part of the game, and then the model basically kind of knows what that element does and tries to allow you to interact with it. Right?
Yeah, and it knows that stuff can be hit and explode and all that.
All right, so we said we'd let people try it. What I might do is just pass it on the first row if anybody wants to try it out. All right, just give me back my controller later. Okay.
Who's brave enough?
Yeah, and I think one thing we want to highlight is that we all know that AI research is progressing really quickly. So even in the month since you published the paper, you're seeing the real-time capability, and also you're working on an increase in resolution as well.
Yeah, increasing resolution.
Oh yeah.
Dead.
You're playing the model, not the game. Yeah, we've been pushing to increase resolution. We've been pushing to reduce the amount of data that goes into this model. So as mentioned earlier, the research we published in Nature, we kind of gave ourselves the luxury of working with essentially an infinite amount of data. And so now recently, we've been really pushing to see how little data can we get away with before we can capture a scene reasonably consistently. And all our models are trained entirely from scratch. So we're not using pre-trained model. We've been pushing all the way down to 60 hours of gameplay recordings to capture a level in a reasonably complex video game. So lots of stuff is even progressing more quickly than I would have anticipated. And I think a lot of that progress is also coming out of that dialogue and collaboration with others, which I'm super grateful for.
I think that it's really important to note that because the technology is evolving so quickly, it's important for us to engage as a community in where is this technology going, what are the tools we want to shape and build with it, because it's gonna come up on us really quickly. So I think panels like this is really key. I guess one of the things that I think we showed was there are gaps in the model. So there are places where there's no data, so then you just jump and then there's it's just black. In fact, maybe that should be a challenge that we ask people to try to break the model. And so, we're not trying to present this as hey, it's the game and it's seamless. There's gaps. So, what do you think of these gaps? How would you address them?
Mm-hmm. All of those gaps are, like you're saying, they're interesting starting points for these research branches, for exploring what's possible. And the reactions we get from people playing this really vary widely. So some people look at it and they're like, oh, there's a gap, the model broke over here, or I went out of distribution and it didn't know what to do. So go and improve it and collect more data and fix these bugs. And then we also talked to a designer recently, and he was like, well, it's too much like the game. How can you make it more unexpected? How can you really make use of the characteristics of the model? For example, you can turn to a wall and you don't know when you turn back whether you're still in the same spot or not. Can you use that to create Escher-like geometries that maybe would be really, really hard to do in traditional ways? So there are at least some of those pressures of make it more like the real game, and there's others like make it nothing like the real game and just explore what's possible on the boundaries. And I really like that dialogue, and am playing with those two extremes in a way.
Yeah, I think there's a interesting question. Like, while I don't necessarily believe that games will all be built this way, I can imagine there will be some genre of game that is like, you know, it's some hallucinatory game where it's part of the lore. You know, you've taken some space mushroom and now things are evolving.
Have you seen Bleeding Edge?
Yeah. So I mean, I've seen most games. But
everybody should go try it out. It's a beautiful game.
And so I think there is like this ability to also get creative in terms of like what new types of genres could exist, and how do you also build the lore around it to encapture this, right? Like, you got thrown into some metaverse portal, and now you're popping up in these different worlds where it makes sense that physics is breaking. And I think that's also just a design challenge. But I do think like where I would see this going is, where do we start selecting the top problems? What takes, you know, for example, hundreds of weeks of time to do basic things that, for example, this could be applied to? And I think that's the next question, like, that would probably the community needs to come up with together, which is like, where are the big areas that we think this could be immediately applicable to that would really make our lives better, and unlock completely new game experiences? And then I think we need to start collecting data on those and feed the research community so that they can make strides on it. And I think that's where this starts to be this interplay between, on the production side, where I'm sitting and where Katja's sitting, which is, how do we start to identify those problems, communicate them upstream, and start building that kind of, you know, beautiful loop? Because I think that's where a lot of great collaboration sits, rather than, for example, us pointing, you know, you guys aren't taking our stuff up quickly, you guys aren't building production ready stuff. Well, that's not how it works. It works through that sort of like long-term collaboration. And so I'm super excited to kind of see gaming and AI come together, because there's so many resources going into AI. Now we're bringing it into gaming. It's an exciting time, I think, really.
I just wanted to say I couldn't agree more, and I'm so grateful for being here and having those conversations.
Yeah.
And Katja, I think one of the things about furthering this dialogue in the games community is being open. And so open sourcing the models, open sourcing the UIs for people to try out, right?
Absolutely.
Yeah. Okay, so I think we're gonna wrapping up now. So I have final questions for the panel, which is, there's this really great interplay between research and tool making. Katja, as a researcher and thinking about furthering sort of AI frontiers, what's the one thing you would ask of tool makers like Kylan or game development teams that you would want from them and you would ask of them to start doing to support you in the work that you're doing?
Great question, and I think, Kylan, you already touched on many of those. So I cannot emphasize enough how important this dialogue is from very early stages of the research. And I'm like comparing to, for example, some, you know, not the majority, but some of the work I see coming out of academia is like dreaming up scenarios and then pursuing them for years without any reality check. And I don't want to live in that kind of bubble. There's a real opportunity here with research progressing fast, technology becoming real enough so that we can have real conversations, and any kind of thoughts people share with us, any direction they can give us, that will influence where this research is going. And I think that is the most exciting space where this can take place, because we'll be able to evolve this technology together.
Mm-hmm.
I got distracted watching it.
No.
Kylan, I guess as a tool maker, as someone who works with game teams to bring these research, these technologies into something like playable experiences, what's the thing that you would ask of research teams?
So I think research operates in a world of like fleets of thousands of H100s or B200s, which are what, $40,000 each. The world of gaming exists at a most at a 5090 if you're like a really hardcore gamer. And so I think that we need to start building smaller models that are hyper efficient and run very well on a broad variety of devices. I think that's simply it. So for example, I would give a research problem to a researcher and say, all you have is a single 4090. You have to do all your research and development on that. And that's basically your goal. And
Nice.
There you go. All right, so more of that. So we need more small things. That's basically, I think, what the game development world needs is super small, efficient models in different modalities, and then we'll be clear to run.
Awesome. Well, thanks very much to our panel today. Thanks everybody for joining us. This has been phenomenal.
Yeah,
Feel free to come up and chat with us.